Good morning, everyone, and welcome to this lecture. This is lecture number 9, and we are dealing with motion of a charge in a magnetic field. Now, as we have seen in the previous class, we had seen the value of force acting on a charged particle, and we had seen in what all cases force depends on. We have also seen that force depends on the angle between V and B. So, taking that into keeping that into mind, we will move ahead and see what is the effect of this angle and how does it affect. So, let us write the next heading: motion of a charge. Motion of a charged particle or a charge inside magnetic field. What type of motion a charged particle will have inside a magnetic field? Now, this motion depends on the angle between V and B. So we'll do it case wise. Case number 1, if theta is 0 or 180 degrees. When I say theta is 0 or 180 degrees, what I mean is the magnetic field or the velocity, they both are parallel to each other or anti-parallel, opposite of each other. So we have this case where velocity may be like this and your magnetic field may be like this in the same direction, or you can have velocity in this direction and magnetic field in this direction. They are opposite or in the same direction. In that case, what will happen, my dear friends? In that case, the force acting on the particle will be 0 and the particle would continue its original motion. Whatever the motion it was following, it will continue its original motion and nothing will happen because the force acting on the particle is 0. I hope you understand this, everyone. Yes or no? Okay, this is case number 1, when the angle between force and velocity vector is 0 or 180 degrees. Then we will move on to case number 2. I hope everyone has noted this case. Case number 2, when theta is 90 degrees. When I say theta is 90 degrees, your velocity may be like this and your magnetic field may be like this, or your velocity may be like this and magnetic field may be going inside or magnetic field may be coming outside. All these cases, your angle is 90 degrees. In this case, my dear friends, what is going to happen? That force is going to be acting, which is maximum. That will be Q into V into V. This maximum force, this force will be constant in magnitude. Please remember this. This force will be constant in magnitude, but will change in direction. But will change in direction. Number 2, velocity will be constant in magnitude but will change in direction. So, same as force, velocity will be constant in magnitude but it will change in direction. At the same time, I can write the same thing for acceleration as well. Acceleration will be constant in magnitude but will change in direction. Now, force is constant in magnitude, changing in direction. Velocity is constant in magnitude, but changing in direction. Acceleration is constant in magnitude, but changing in direction. What type of motion this particle will follow? The particle will follow uniform circular motion. The particle will follow uniform circular motion UCM. Uniform circular motion is the motion of the particle where V and B are perpendicular. I'll give you 2 minutes to note this down. Let me know once you are done. Okay, then let's move ahead. The particle is going to follow what we say as uniform circular motion. Now, how what all things you must remember about this? So let me go ahead. Now, remember this force, this force, this force that we are talking about, this maximum force QVB, this force will be pointing towards the center of this circular motion. So that is the next point that we will write. Force and acceleration will be directed towards the center of the circle. Force and acceleration will be directed towards the center of the circle. Now the next question is, how will you find out the center of the circle? So basically, if you know the direction of force, you can find out the direction of the circle or direction of the circular path. For example, you can see here in this case your velocity vector, your velocity is in this direction. Your velocity v is in this direction. The particle is moving with a velocity like this. It is a positive charge. As you can see, the charge is positive. The charge is positive. Velocity is in the right direction. You can see the magnetic field is going inside. All this is magnetic field. Magnetic field is cross. That means magnetic field is going inside. Angle between V and B is 90 degrees. And you can see where is the center of the circle. So you do V cross B. V is here. B is inside. V cross B. And you can see the force is pointing upwards. Force pointing upwards means force is in this direction. The force is in this direction, and as you can see, it is pointing towards the center of the circle. This is the center of the circle, and the force will always, you can check it, the force will always point toward the center of the circle. Do we understand this, everyone? This force, this force which is equal to Q into V into B, is always pointing towards the center of the circle. Do we understand this? This force is always pointing towards the center of the circle. In fact, this force is going to give you the centripetal force. So QVB will be equal to your centripetal force mv square by r. Where what is r? R will be the radius of this circle. R would be the radius of the circle that you are going to have. R is going to be the radius of the circle. So from here you can find out what is the radius of this circle. The radius of this circle is mv by qb. The radius of the circle that this charge makes will be equal to mv by qb, a very important formula that you must remember at all costs. A very important formula that you must remember at all costs. You can write this formula in different ways. This is also equal to p divided by qb. What is p? P here is the momentum, my dear friends. You all know it. That will be equal to root over 2m into k, where k is your kinetic energy, divided by qb. You can also write it like this way. Now, kinetic energy k can be written as q multiplied by v. So, I can also write this as 1 by b into root over 2mv by q, where v is the potential difference. So these are the various ways in which you can write the formula for a radius of this circular path. Radius of the circular path, and all these are same. They are not different. All these are same. Do we understand this? Yes or no? No or yes? I'll give you 2 minutes to note this down. Let me know once you are done. Okay, then let's move ahead. This was radius. And what do you need to remember about the radius? This radius of the circular path, point number one, is directly proportional to V, which is directly proportional to momentum P, which is directly proportional to root over kinetic energy. This is one point that you must remember. Now, the second point that you must remember about this circular motion is always the time period of circular motion. Now, to get the time period of circular motion, time period of circular motion is always equal to 2 pi by omega. So, we have already seen this formula. Time period of circular motion is 2 pi by omega. Now, how do you find this omega? This omega is always equal to V by R. Omega is the angular velocity. It is always equal to V by R. Do we understand this, everyone? Are you able to hear me? Get this? Yes or no? Okay. Omega is V by R. If you divide with V by R is mv by qb. You will get omega. You will get omega as qb by m. You will get omega as qb by m, and that is a very important formula that you must remember. Omega is qb by m, a very important formula that you must remember. Omega is qb by m. That means omega does not depend on velocity. Once we understand omega, you can also write time period. Time period is 2 pi by omega. So the formula for a time period becomes 2 pi m by qb. 2 pi m by qb becomes your formula for time period. This time period does not depend on the velocity, so that is the next thing you can write. Time period does not depend on velocity. This time period does not depend on velocity. It depends on Q by M, which is the charge by mass ratio. So these are the three formulae that you have to remember: the formula of radius, the formula of time period, and the formula of omega. I hope all of you understand this. I'll give you 1 minute to note this down. Okay, then let's move ahead. Now I will show you a table where we will try to compare the radius of path described by proton and an alpha particle. Now remember, what is an alpha particle? These are the questions that I have seen a lot of times. Alpha particle. Anyone has any idea what is an alpha particle? Alpha particle. Proton, everyone knows what is a proton. An alpha particle is helium nucleus. It is the nucleus of helium atom. Alpha particle is helium nucleus. So basically what they do, they take out the electrons from the helium atom. If the electrons are taken out from the helium atom, it becomes a helium nucleus. Now remember, if the mass of the proton is m, the mass of the alpha particle is 4 times m. It has 2 neutrons and 2 protons, so its mass becomes 4 times m. If the charge on the proton is p plus, which is same as the charge of electron but positive, if I call this as, it will be 2 times the charge of an electron. The charge of a proton is 4 times the charge of an electron in the positive sense. Now, if you put all these things together and find out the ratio of the radius in various cases, in first cases when the velocity is same, in second case when the momentum is same, in third case when the kinetic energy is same, and in the fourth case where the potential difference PD is same, you can find out the ratio of radius of curvature, and this there is one term which is known as your ratio of curvature. Now remember, this curvature of a body is inversely proportional to the radius. That means a body which has less radius has more curvature. A body which has more curvature has less radius. Because I've seen question comes on curvature. How much is the curvature? So if there is a question on curvature, then you must remember that it is the inverse of radius. If radius is more, curvature is less. Do we understand this, everyone? I gave you 2 minutes to note down this table. This is not a table, beta. These are questions that have come in your exam. These are questions that come in your exam. These are the questions that will come in your exam. So I'll give you 2 minutes to note them down. So I guess you have noted this down. This is the case that happens when, and we will do some questions also on this. This is the case that happens when the velocity of the charged body is perpendicular to the magnetic field. Let us first discuss the third case, case number 3, theta. Let me write it like this. 0 is less than theta is less than 90 degrees. So my velocity is like this and the magnetic field is like this. It is at some angle theta, and this angle is not 0 or 90 degrees. In that case, what type of path this body moves, that path is known as a helical path. That path is known as a helical path. What do you mean by helical path? It moves in circle and it moves ahead. Moving in circle and moving ahead, that is a helical path. Now, how do we understand this? So, okay, let me draw it again. What is happening? Okay. Now, how do we understand this helical path? So, what I'm going to do, I'm going to draw my magnetic field in this direction. This is my magnetic field. The magnetic field is pointing in this direction and my velocity is pointing out in this direction. This is my velocity v. Now what I can do is I can resolve this velocity into two components. What are those two components? One component of that velocity will be coming in the direction of magnetic field, and the other component of the velocity will be coming perpendicular to the magnetic field. I will call this component as V perpendicular and I will call this component as V parallel. So V parallel is that component of velocity which is coming parallel to the field, and V perpendicular is the component of velocity which is perpendicular to the magnetic field. Because of this component, it will move in a circle. Because of this component, it will move in a circle. Because of this component, it will move ahead. So, it will move in a circle and it will move ahead. Move in a circle and it will move ahead. It is like your screw. When you turn your screw moves ahead. The thread on your screws are helical in nature. Do you understand? The thread on the screw that you use, if you have used a screw, they are helical in nature. So what is going to happen is this body is going to move ahead and move in circle. Do we understand this? Here what we have drawn is we have a magnetic field which is going in this direction, and we have a velocity which is in this direction. The angle is given as theta. So from here you can find out the radius of this circle. The radius of this circle r. The radius of this circle is given by m into v perpendicular divided by qb. M into v perpendicular divided by qb. This v perpendicular is the velocity which is perpendicular to the magnetic field. V perpendicular is the velocity which is perpendicular to the magnetic field. So this becomes mv V sine theta in this case divided by Q into B. Do you understand this, everyone? The time period is the time taken to complete one revolution. It remains same. It is 2 pi m by QB. It is 2 pi m by QB. That is the time taken to complete one circle. We have something known as pitch. We have something known as P or pitch. This pitch is the distance traveled. This pitch is the distance traveled in one revolution. This pitch is the distance traveled in one revolution, and the value of this pitch, P pitch, is V parallel, the parallel component of velocity, multiplied by T, which is the distance it moves in one time period. In this case, it will be given by 2 pi m by QB multiplied by V cos theta. So these are the formulae for this particular case. Everyone understands this? Yes or no? I'll give you 2 minutes to note them down. Then let's move ahead and see the last thing of this, which is known as the Lorenz force. Lorenz force. Now, what is this Lorenz force? Now, if a particle is under the influence of both electric and magnetic field, electric field is also there and magnetic field is also there. So how do you find a force acting on that particle? That force acting on the particle is found by the vector summation of both these forces. So what do? You find out the electric force. This blue one is the electric force, Fe, F electric, and this green one is the magnetic force due to magnetic field. You add these two forces vectorly and you get the net force acting on the particle. This net force acting on the particle is known as your Lorenz force. So Lorenz force is the summation of electric force and magnetic force. When you add them vectorly, you will get your Lorenz force. Do we understand this, everyone? I'll give you a minute to note it down. So I think you have noted this down, Lorenz force. We are done with this force on a charged particle. In the next class, that is tomorrow, we will go ahead and solve some questions on this. So I'll see you in the next class where we will solve some question on this and then we will move ahead. So take care and have a good day. I hope you have understood what we have done in today's class. Yes or no? Okay, great. So I'll see you tomorrow. Take care. Bye bye.